So once the organism dies, the radiometric clock starts for the parent material, which is again carbon-14, to start decaying to the daughter material, which is going to be nitrogen-14. The amount of the carbon-12 and carbon-13 will remain the same because they are stable isotopes. And so the proportion of carbon-12 and carbon-13 to any remaining parts of the carbon-14 are going to help determine how much carbon-14 remains within the sample. This type of dating tool is limited to carbon-bearing materials like wood, flesh, or cloth, if that is made from plant matter, for example. For example, radiometric dating has been done in many historic artifacts or garments, like the one that you're seeing on the slide here. This is the Shroud of Turin, which is a cloth that is believed to be the cloth where Jesus Christ was wrapped in upon his burial. So this and many other types of historic artifacts have been dated using this dating technique. Although numerical dating has helped to narrow dates for some of the period in the geologic timescale, the task is still quite difficult. The main difficulty arises from the fact that not all rock units can be dated radiometrically. Again, because they do not possess the radioactive isotopes that are formed within the crystals. Or even if they do, sometimes these isotopes are within crystals that incorporated within the rock much after crystallization of the mineral. So it is not representative of the true age of that rock. This is true for all the detrital sedimentary rocks, for example, and also for some of the metamorphic rocks. So it is hard to know if some of the minerals from metamorphic rocks were recrystallized, so they were formed by recrystallization and hence potentially have added radioactive ions, or have simply experienced deformation from a previously existing mineral inside the rock. So there is the possibility for error from either type of those two groups of rocks being dated numerically. So typically, geologists will date igneous masses instead. These igneous masses that they date tend to be near the rest of the rocks that they're interested in. So using the other principles, such as the relative dating principles and the fossil record, they're able to estimate the age of the sedimentary rocks and the metamorphic rocks that are nearby the numerically dated igneous rocks. So this can be seen from the example in this slide, for example. In this case, dates have been determined for the volcanic ash right here at 160 million years old. Obviously, by the principle of superposition, we know that the strata that lies below that ash bed is older than the volcanic ash bed, and that the strata that lies above it is going to be younger than that volcanic ash bed. Also, by the dating of this igneous intrusive dike, we know that it's of 66 million years old. So it can be assumed that the Mesa Verde Formation, the Mancos Shale, and the Dakota Sandstone are all going to be older than that specific dike. And we know this because the dike itself is cutting through them all. So using the principle of cross-cutting relations, we know that these three layers, the Dakota Sandstone, Mancos Shale, and Mesa Verde Formation, are going to be younger than 160 million years old, but they're going to be older than 66 million years old. And lastly, we know that the Wasatch Formation has got to be younger than 66 million years old, due to, again, the principle of superposition. So, geologists have divided the whole of geologic history into units that vary in length. Together, all of these units compose the geologic timescale over its history, which is the same that I had shown you earlier in the lecture right here. This one has a lot more detail to it, so if you're curious, definitely go ahead and check it out. But for now, let's stick to the simpler, easier to read one. So the major units were defined during the 19th century by mostly Western European and British scientists, and they were all based on fossil correlation and based on the methods used in relative dating. In the 20th century is when the method of radiometric dating was discovered, and so there were quantitative dates were added to the subdivisions that were initially placed by the relative dating principles and the fossil correlation. So the geologic timescale subdivides the Earth's 4.6 billion years into many different units, and it provides a time frame within which the events of the geologic past are arranged. So by looking at this picture right here in the slide, we see that eons right here represent the greatest expanses of time. So the first eon is the Hadean, then the Archean, Proterozoic, and then Phanerozoic. The Phanerozoic eon, which started about 541 million years ago, it means visible life in Greek. Phanero and means visible, and then zoic is life. So the next subdivisions, or the next subdivision name are eras. So that's going to be all of these guys right here. The Phanerozoic itself has 3 different eras, those being the Paleozoic, the Mesozoic, and the Cenozoic. Paleozoic means ancient life, Mesozoic, middle life, and Cenozoic, recent life. Each era is further subdivided into periods, with the Paleozoic era containing 7 different periods: Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, and Permian. The Mesozoic era is going to have 3 different periods: the Triassic, Jurassic, and Cretaceous. And then the Cenozoic era, which is the one that we currently are in, has 3 periods as well: the Paleogene, the Neogene, and the Quaternary. Each period itself has epochs, which are the further subdivision that we have come with. The Cenozoic is subdivided into 7 different ones, the Holocene being the epoch in which we are at right now. But basically, even though this slide only shows you the Cenozoic having the epochs, each other period that lies within the geologic timescale also possesses epochs, but for sake of clarity within this diagram, they weren't shown to you. But again, if you do want to see more detail, the beginning slide, or one of the beginning slides, contains that very detailed geologic timescale. So check it out if you're curious. So, as an easy way to follow along with Earth's major events, this diagram right here relates the different events that have occurred in the past 4.6 billion years, as if though they had all occurred in the last day. So we see that the whole Hadean eon, pretty much right here, was filled with bombardment of meteorites, and at this time the protocrust was probably forming, again during the first 3 hours of the day. The first origin of life with stromatolites, which are mats of cyanobacteria, came to happen about 4 a.m. The oldest fossils were preserved about 5:36 a.m. Between 6 a.m. and almost 2 p.m. there were abundant banded iron formations being made, which exemplifies a time during which our atmosphere was undergoing major changes. So this is a topic that is covered in depth during historical geology. So if you want to learn a little bit more about it, register for it. At about 2:08 p.m., we started getting single-celled algae. At about 6 p.m., we started to get sexual reproduction. And soon after that, we saw an explosion of life, initially of smaller and more soft-bodied part organisms, and later with organisms that had harder parts as well. We see that the dinosaurs did not appear until 10:56 p.m., that mammals didn't appear until 11:39 p.m., and that humans, as we know, humans, Homo sapiens sapiens, did not occur until the last minute or so before midnight. So that's right, we've only been around for about less than 1/100th of the Earth's history. Okay, so if this lecture has taught you anything, hopefully it is that geologists will date anything, as the message in that SUV says. We will date things using fossil correlation, relative dating, numerical dating, and even through dinner and mini golf, as it happened with me and my husband. Good. So with that, we are done with chapter 18, and as always, let me know if you have any question. And I hope that this lecture was fun. It is certainly one of my favorite topics. Yeah, I hope that everything went well. Let me know if you have questions.